we are covering the torsion of circular shafts, a key topic in the Mechanics of Materials section for your FE Civil exam. All the core formulas can be found in your NCEES FE reference handbook, so let's focus on how to apply them under exam pressure. The fundamental formula for shear stress is tau equals T times R over J, where T is the internal torque, R is the radial distance from the center, and J is the polar moment of inertia. The exam will almost always ask for the maximum shear stress, which occurs at the outermost fiber, so you'll use the shaft's full radius for R. For a solid circular shaft, the polar moment of inertia, J, is pi times the diameter to the fourth, divided by 32. Be careful here. The formula uses diameter, not radius. A common trap is to use the radius in the J formula, which will lead you directly to a wrong answer choice. For a hollow shaft, J is calculated as pi over 32 times the difference between the outer diameter to the fourth and the inner diameter to the fourth. Next is the angle of twist, represented by the Greek letter phi. The formula is phi equals T times L over J times G, where L is the shaft's length and G is the shear modulus or modulus of rigidity. A critical exam point is that this formula will give you the angle of twist in radians. Expect the question to provide answer choices in degrees. You must remember to perform the conversion by multiplying your radian answer by 180 over pi. Forgetting this simple step is a frequent mistake. To help remember the angle of twist formula, use this mnemonic, the Lazy Jay Goose, which helps recall the order T, L, J, G. When a shaft has multiple segments with different torques or diameters, you calculate the angle of twist for each segment and add them together, paying close attention to the sign convention for the direction of the torque in each section. The final piece is power transmission. The primary equation is power equals torque times angular velocity, or P equals T times omega. The number one trap on the FE exam for this topic is units. The formula requires omega to be in radians per second. However, exam problems almost universally provide the rotational speed n in revolutions per minute, or RPM. You absolutely must convert RPM to radians per second by multiplying n by 2 pi and dividing by 60. If you plug RPM directly into the power formula, your answer will be incorrect, but it will likely be one of the provided distractors. For example, if a shaft transmits 10 kilowatts of power while rotating at 1200 RPM, you would first find omega, which is 1200 times 2 pi over 60, giving you about 125.7 radians per second. Then you can rearrange the power formula to find the torque. T equals P over omega, which would be 10,000 watts divided by 125.7 radians per second, to solve for the torque in Newton meters. Mastering this unit conversion is essential for success. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.